So the reason we don't see Canada and Mexico, let's invisible back and forth, and I remember we changed the symbology and nothing happens, right? And what was wrong? So now let's look at their coordinate system again. This is this, and they are this again. GCS North America 1983, and let's see what happened to Canada, Mexico. It's undefined. And what about US, United States, and the same. What about for the lakes layer? They are the same. However, this one we need to do something about it. So now we're going to put coordinate system so that we're going to see. Okay, the same way we're going to ArcGIS box and the project tool. This time we're going to do Canada and Mexico. In input coordinate system, we're going to do this one and hit OK. And we use the project and it already defined for us, and then we click OK and output value. We already have this. Output coordinate system, hit OK. This one is not input, sorry. And then hit OK. This one is not no, and hit OK. And now, finally, we saw our, we can move this down, and this one wouldn't show because it was undefined. And we're going to change the symbology to gray, and out as for gray, and now it looks really nice. A very nice map showing up. Now, yay, we fixed the problem. And we're going to go ahead to remove this layer and the same here, and we're going to copy and paste it here. There. And for our Alaska, we have Canada and Mexico as well. Now we're going to do the next step is we're going to project the Hawaii data frame. So we're going to project for Hawaii and right click on the property in here. We're going to choose projected coordinate system, and then we go to continental, the same, and North American. This time we're going to choose Hawaii Albert equal area conic. Hit apply, hit OK. And now we're going to zoom to Hawaii. Okay, now we're going to zoom to layer, and then we're going to activate property. Oh, okay. We're going to activate. And now we go back to the data view. And now we're going to zoom to Hawaii. Right here. Hawaii. And then we go back. So now we have Hawaii, and we can make it a little bigger and center it a little better. Now Hawaii shows, and we can move to pan and center a little bit more. And now we have our lovely Hawaii back down here. And we're going to close this out, and we need Alaska. So now we're going to right click on this. The same we have to do the projection for the data frame. And go to projected coordinate system, continental, North American, choose the first one, Alaska, Albert equal area conic, and hit apply, hit OK. And now we're going to activate Alaska and go back to here, and let's zoom to our Alaska. Okay, now let's pan there. Perfect. And now we go back to the data view. And now we still need a little bigger for this layer. And now it's activated. We can go back here. And or we can just type here, change into 66. Hit enter. Maybe 46, a little bigger. And then we change it into palm, and we've centered it now. Lovely. 46 still big. We will change it back to 56. Delete the 4. Whoop, it's 1. Okay, now we need to change in 1. Okay, now palm down. Perfect. Okay, now we have our Alaska. We move this back in. So now, our mainframe needs to work a little bit for it to show up. And we activate this one. And let's do maybe 22. Okay, and then let's move around. Very nice. So now, perfect. Our map shows perfect for the United States population 2000 to 2010 change. So now each of the 3 data frame has a variance of the Albert equal area projected coordinate system. Data frame properties can be adjusted at any time. So it is also possible to work on individual data frame in data view mode. To change the data display, simply activate a data frame. But now I think we've already done our job here. Good job. So now we can go to File and Map Document, and it's already stored that. And we can just hit Save. And it's a lovely map. Good job. And we're going to the next one. Save it. And we're going to close it out. And let's move on to exercise 606C. So now for exercise 6C, we're going to define a map projection. So now to do that, we start the ArcMap. And the map is open in layout view. There are 2 data frames here. And one is state plane and the other is universal transverse locator UTM. The state plane data frame is active because it's in bold. Both frames include a U.S. states layer. Zoom to the state of Colorado. Colorado. Notice the slight difference in curvature of the state boundaries. Curvature, state boundaries. Not much a difference right now. That the left data frame is projected to the Colorado North State Plane coordinate system, and the right data frame is projected to the UTM Zone 13 coordinate system. So the state plane coordinate system SPCS, State Plane Coordinate System, was developed in the 1930s by the U.S. Coast and Geodetic Survey of the National Oceanic and Atmospheric Administration to provide a conformal mapping system for the country. It is commonly used for country and statewide surveying and data applications. It is not recommended, however, for use across state lines to maintain accuracy and minimize distortion. Larger states have multiple zones. The UTN divides the Earth into 60 zones, each 6 degrees of longitude wide. There is almost no distortion at the center of each zone and gradually increasing distortion outward from the center. UTN grid coordinate systems are expressed as a distance in meters east of the central meridian, known as easting, with an assigned value of 500,000 meters, and a distance in meters north of the equator known as northing, with an assigned northing value of 0 meters. So now we're going to explore about the differences and uses of state plane and UTN coordinate system. Now we're going to add the Colorado shapefile, our catalog. So now zoom to my data, Colorado, right here, Colorado shapefile, to the state plane data frame. Oop, what did happen? Okay, so now a window pop up. So ArcMap displays a warning that the layer is missing spatial reference information. So now click OK to close the warning message. So you may notice quickly that something is wrong. ArcMap added the layer. You can see it in the table contents, but cannot be visible in the state plane data frame because the Colorado county's layer did not have a defined coordinate system information. So ArcMap does not know where to properly place it. So we right click the Colorado county's layer. We're going to right click, hit OK first, right click on it, and we're going to see zoom to layer. Where did it go? Okay, zoom to layer. And we can go back to data view. Then we can extend it. Wow, Colorado is in Los Angeles now. So it is so funny that surrounding states become back in California. So we right click on it, go to property, and you can see the coordinate system is undefined, and we're going to see this is under the state plane, GCS North America 1983, and we can see the state plane. It's state plane Colorado Central Phipps 0502 feet. State plane use feet as the units. So what are the spatial extent value for Colorado's county layer? So now we're going to look at the source and to tell the answer. So top is 466,927, and then the bottom is negative 39,875 point something, and left is negative 1146, and to the right is negative 504 something. So since ArcMap had no information to use, it drew the Colorado county's layer using a projection within latitude and longitude coordinates as if they were XY coordinates in the state plane coordinate system. As a result, the layer is being placed in California, which is obviously incorrect. It is a situation like this. It is up to you to find the appropriate coordinate system information.